Okay, well, you guys have made it. The last review sheet of the year. It is on compound interest. We have done a couple compound interest already in our reviews back in the sequences and series review, but it was brief, so we thought we'd dedicate 4 example problems solely to just the compound interest formula. All right, so problem number 1, they want to give our answers correct to 2 decimal places. It says Jen invests $2,400 in a savings account that pays interest at a rate of 4% per year compounded annually. She leaves the money in her account for 10 years, and she does not invest or withdraw any money during this time. Letter A, calculate the value of her savings after 10 years. All right, so I've given you the compound interest formula over here and what all the variables mean next to it. We are calculating FV, the future value. All right. So it's the present value, which is how much she put into the savings account, which is $2,400, times 1 plus the R value, which is the nominal annual rate of interest, which, again, we do not want to change to a decimal in these examples because a part of the formula is dividing it by 100. So we're going to leave it as 4. That's divided by 100 times K. K is the number of compounding periods per year. It says it's compounded annually, and that word annually just means once per year. So our K value is 1. Then we're going to raise that to the K times N power. Again, K is 1. We multiply it by N, and N is the number of years, which they give us as 10. So we're going to type this right into our calculators. Again, we're going to round our answer to 2 decimal places, so it comes out to be $3,552.59. It says the rate of inflation during this 10-year period is 1.5% per year. Calculate the real value of her savings after 10 years. So inflation is something that happens in real life. It's a way that kind of makes the money seem more than it actually is. So technically, she does not have $3,552.59. It's a little bit lower than that. And how we can calculate this is by using our formula again, but with a slight change. So we're going to calculate FV again. One change is our present value is now we're going to use our answer we got in part A. And when in our parentheses, instead of it being 1 plus R divided by 100 times K, it's going to be 1 minus. The R value now is the 1.5%, but everything else stays the same. So it's 100 times 1 to the 1 times 10 power. All right, and we'll type this into the calculator. So this gives you the real value of her money after 10 years with the inflation included, and we're going to round it to 2 decimals again. So it's $3,054.27.